Hello, everyone. Welcome to the Astro Geek Comics, and this is our second episode of Keeping Up with the Universe. Over here, we talk about the latest research that is happening on the frontiers of astronomy, and we bring that research to the general public by directly talking to the researchers that are doing that particular research. And today, with me, I have a very wonderful guest, Rose Waugh, and she has been studying the magnetic fields around stars. She's been studying something that is very interesting called prominences, right? And we are going to learn about what that research is, about what is the importance of that research. And I'll be asking Rose to just introduce herself before we move on with the session. Hi, Rose.
Hi, thank you for having me. It's great to be here. So I am in my final year of a PhD research at the University of St Andrews in Scotland. And yeah, like you say, I do research into stellar prominences, which are essentially kind of clouds that form around stars. And I guess I don't want to reveal too much because there'll be questions coming. So.
Thank you so much, and it's my pleasure that you've joined. So yes, you've given us an idea what the prominences are. So everyone who's watching the live right now and will be watching it later, just to let you know that you can put up your questions on the comment, and in the end, we'll just try to bring them during the live also, so that Rose can answer them. So let's begin our interview with the first question that I have for Rose, which is, so what is your research based on? What's the main hypothesis around your research?
So I guess it depends a little bit. So I don't have like one hypothesis for the entirety of my PhD. I kind of have done like a few different things related to prominences, but ultimately what I do is I try to find mathematically where these clouds might form around different types of stars. And this is kind of based on observations, like they have been seen on different stars, but it's very difficult to know exactly where they are. And so if we can predict using maths where they might be, that can help us to understand about the prominences themselves, but also about kind of a lot about the star as well. So where they form will depend on, lots of things about the star, how active it is, or what its magnetic field is like. So that's why I do what I do, I guess.
So I think I would also want you to explain the term prominences. What exactly are prominences in terms of astronomy?
So on the sun, you might have seen pictures of prominences. They're kind of like big clouds, and they form kind of in loops where the magnetic field is. And they're just kind of areas of the atmosphere, of the corona of the star, where there is a particularly dense amount of material. And so that's why it's kind of like a cloud. And on other stars that are younger than the sun and they are rotating a lot quicker, you find kind of a different kind of prominence where you have the same idea of a cloud, but the way that it forms is slightly different.
So these prominences around the quick rotating stars that you're talking about, they are not like loops?
Not so much, no. The magnetic field that you would need to support them, they form really, really far out from the star. So on the sun, these prominences that we see are, maybe 100 to 1,000 kilometers above the surface. They're not that far up in the sky, inverted commas. Right. But on these really rapidly rotating stars, they're really far out. They're, like multiple stellar radii above the surface. Okay. They're really, really far out. So they don't kind of look quite the same. If they were to take up an entire magnetic loop, they would be completely ginormous. So but it's a similar idea, yeah.
Okay, so in the case of fast rotating stars, it's actually like a cloud.
Yeah,
floating high, far above the surface. Okay,
Very fun.
interesting. So, what you found interesting was how the prominences form and what are the features that predict, or you can use to predict where they'll next form, right?
Mhm.
So, in brief, I guess that helps us to understand more about the magnetic field of the star, right?
Yeah.
So, I guess now we should move on towards the next question, which is, what made you choose this particular topic for research?
Um, so I guess I didn't do my undergrad in astronomy. I did theoretical physics, and the classes that I took in my undergrad, I really liked, like fluid mechanics, and I really enjoyed magnetohydrodynamics. So ultimately, fluids, but with a magnetic field in it. Um, and I just kind of ended up here by accident, I suppose. They were the things that I enjoyed, and it happened that there was a master's project that I could do that happened to be in astronomy that was in that area that I liked. And and then I ended up here. So I guess it was kind of an accident. It was more the fundamental physics rather than the astronomy that brought me here. And now that I'm here, obviously, the astronomy is keeping me here. But
So I guess it's a fortunate accident that it happened that
yeah.
brought you towards astronomy. And over here, it also makes the point clear that, usually we choose a particular major, we choose a particular specialization, and then we get panicked that, okay, it's hard. It's maybe not my cup of coffee, or I'm not finding it interesting. And students usually find it hard to leave that field and, they doubt themselves. I'll have to restart everything. But I guess now looking at this particular thing that you started with theoretical and now you've come towards astronomy should be a motivation that things can be brighter.
Absolutely. You don't have to feel like you're cornered into something just because that's what you're majoring in. You're going to learn a
Right.
lot of skills from your major, regardless of whether you want to stay exactly in that field or not. So you can apply them elsewhere. I agree. I also felt cornered. Like I had felt cornered into theoretical physics, I guess, and I really hated quantum field theory. I don't know if you've come across this in your course at all, but I hated it, and it was just so difficult, and I didn't understand. And yeah, I didn't. I guess I didn't realize that my skills would be applicable anywhere else, but they are,
Mhm.
and you only realize that retrospectively. So I think it's always important to pass that information on to people so they don't have to feel like that.
Yeah, I guess we can both cry together over theoretical physics being hard because
Yeah.
I face the same problem because I'm not very great at maths. And then, all of these different equations and these different mathematical tools. So I've always tried to keep a foot distance from theoretical physics, but it always creeps in from some corner.
Yeah, it has a habit of doing that.
Okay, so I guess since we now know why this topic was chosen by you, let's understand how you are carrying your research on this topic.
So mostly I do a lot of mathematical modeling of things. So ideally that involves for me kind of working out the basic physics or maths with pen and paper, like, like I guess you would with tutorial problems or whatever, you do as an undergrad. And then ultimately I end up having to do some coding. So I am not a very strong coder. Some people are very, very good at it and very much enjoy it. And I'm not one of those people. Um, I like having done the coding, but I don't enjoy the process at all. So for me, I use kind of high level, I guess, computing languages. So I use Mathematica quite a lot, which does not involve too much brute
Mhm.
force like Fortran or Python and stuff like that. Um, So yeah, mostly a lot of calculus with pen and paper, and then a bit of coding. I don't have any data or anything. It's all theoretical.
Okay, so when we think of astronomical research, we usually imagine people out there, and even my initial reaction to you studying about magnetic field of stars and prominences was that a part of it would have involved, watching through the telescopic data of different stars, and then finding out, okay, this is coming out like this, and how can we explain this particular aspect. But it's quite surprising that a lot of that research, even though in a practical field like astronomy is so much of pen and paper, and these days it's mostly modeling, right? So the modeling that you did, and you said it was in the language Mathematica, can it also be done in other languages like Python, or is there an advantage that Mathematica has?
Not at all. You can do it in probably any language that you wanted. It's just that that's the one that I feel most comfortable with.
Mhm.
But there's no reason why it has to be in there at all. I guess the advantage for me is that a lot of the work that I do in general is quite, like I would solve a lot of things in pen and paper and I would get an equation out at the end. And so plotting is a lot easier if you have a package that is very good at that. Whereas something like, for example, Fortran is very good if you want to kind of do some hardcore coding, but it doesn't plot very efficiently. So I guess that's
Okay.
the only advantage. But Python is great for plotting if you are confident in using Python. So yeah, I it's very theoretical for me and no telescopes involved. But for lots of people, there is. So
So is that a good thing or a bad thing that there's no telescopes involved?
um I guess for me, I think it's a good thing. Whilst I hate quantum field theory, I am quite fond of theoretical physics because I do enjoy kind of the more maths aspects of
Mhm.
stuff. So for me, having something more theory based and less practical based is definitely a good thing. But not everyone feels that way, definitely. And people are always very surprised when they find out I'm an astronomer who doesn't look in a telescope.
I guess that's everyone has this moment in their life when they realize, okay, astronomers do not necessarily use telescopes.
Yeah,
Uh,
yeah, not all of us.
so, would you say that to be into astronomy, you need to be very good in maths, or like just even an average person who's average in maths can find out a future in astronomy?
Oh, definitely. There are many areas of astronomy, right? So you go into the area that you personally enjoy the most. So if you don't like maths, then you're probably not going to pick to do that kind of area of research. But that doesn't mean that you are excluded from all of astro. There are lots of different things that you can do, whether you like data or calculus or looking through telescopes or sitting in front of a computer. So there's a lot of variety out there. And I wouldn't say I'm amazing at maths. I just enjoy it. I'm willing to stick at it even when I'm stuck. Even when something is difficult, I enjoy it enough to keep trying, which I think is the main thing. It's not about whether or not you're fantastic at something. It's about how stubborn you are.
Maths requires stubbornness, right? Do not get off that table unless you solve that particular thing.
Yeah.
Oh, wow. Maths has scared me for all my life. So I'll be less stubborn with maths. But yes. So, I think the fact that, looking at the Nobel laureates and a lot of other scientists who've done so great, people have this image in them that scientists have to be very good, right? They have to be very smart. They have to be that they have to get perfect scores in maths and physics, and only then can you be a scientist. Which is now I'm learning that actually, okay, yes, most of the science has been pushed ahead by people who are actually average in terms of maths and science, and they are the majority of the scientists who carry the field ahead.
Yes, for sure. You don't have to be the best. I think people, obviously the people that get highlighted are people who have been kind of seen as incredibly intelligent, and things like that. But everyone's human, right? Everyone has things that they struggle with. And the majority of people, I think, scientists are quite normal, really. People are just scared off, I think, because if they haven't enjoyed things like maths at school, they assume that everyone that does it must be very, very clever. But it's a stereotype which isn't true, I think.
So keep practicing, be stubborn. So coming on to the next question that I have for you, Rose, is any interesting thing that you can tell us about your research that revolves around the main object?
Well, I guess I obviously think a lot of it is interesting, otherwise I wouldn't spend my life doing it. I don't know. I guess for me, the thing I find most interesting is that these clouds can form on lots of different types of star. So they're very common, I suppose, in that sense. But the stars themselves could be very different. So, we talked about how they exist on the sun, but they also exist on stars that are a lot younger and rotate very quickly. And these clouds are very different if you look between the two stars, but they exist in both cases. So I think personally the fact that they're kind of they must be very common is interesting, or at least to me. It's nice to know that they're not just a very niche thing that exists only on one star in one place in the universe.
So was this something unexpected, finding prominences on young stars?
I don't know. I mean, I think when the first paper was published of observations of them, and kind of, I guess initially it wasn't 100% certain that this was what they had seen. I think it probably was kind of surprising, for multiple reasons. I guess the fact that they exist there as well as on the sun, maybe people hadn't thought about. But also it's amazing that we can even see them, right? Like, it's amazing that we have technology to be able to see something that ultimately is just like a dip in the light of the star. Oh, the star's got a little bit darker and it's just a cloud going across the front of it. The fact that we can observe that, I think, is amazing. And that must have been amazing then as well for everyone. I think that's amazing.
Yeah, so you said that we see a dip going in front of the star. So is it something like detecting exoplanets around stars by the light curve method?
Yeah, it's a similar idea of in both cases you have an object that passes in front of the star, and it will affect the amount of light that is visible to the observer. So with prominences, I don't know how much like observing you like to do, but with prominences, we observe them in the H alpha line, and that's where you see the dip in light intensity. But yeah, it says the same kind of idea, right? So
yeah, so because prominences, these are mostly clouds of hydrogen blocking the sun, so that is the better range to see the dip, right? Am I right?
Yes, yeah. I'm very impressed.
Thank you. I prepared for this interview. So moving on, and I guess a part of this question has already been answered, that what kind of equipment do you use for research?
Yeah, so I guess a computer and certain software, and a lot of journal articles, textbooks, pen and paper. I guess very normal pieces of equipment, if that makes sense. I don't have anything fancy. I don't use any fancy telescopes or anything. which I guess is underwhelming, but it's amazing what you can do, right, with just kind of things that you would probably have at home on your desk anyway. I don't.
Right. So it's. I'm sorry for interrupting. Yeah, you were saying.
No, carry on. Yeah, I wasn't saying
Okay.
anything.
So I was just saying, yeah, it's actually impressive that the same piece of equipment that's on your desk and mine and someone who's watching this video has been used to do the kind of research that we are talking about. So I also read that you tried to match. You tried to match your simulations with the actual data of stars. So that data was not through the telescopes. What was that through?
Yeah, so that data was ultimately it came from people observing, but I wasn't the person observing.
Okay.
So a lot of the observations have kind of come quite a long time ago now. And so they're all in the literature, and I guess that's where I got the data from. It's from published journal articles. So ultimately, someone sat in front of a cool telescope and did these observations. But I'm not sure I was even born at this point, so it was quite a long time ago.
Wow, so that's such a old research still continuing even on today's date.
Yeah.
I wanted to know that this research, when they see sunspots, so they are not, and the models that you make. So these are not models actually, like we do not have a model of a star and, they do not predict that this is going to be the field like, but it's more of a graph.
So it depends. I mean, I guess I've done a couple of different projects now, and the paper that you read was very much more analytical and just kind of, I guess, maths based without any complicated simulations. In more recent work that I've done, I have had simulations that have been able to predict what the magnetic field would look like. So I have some data that, again, I didn't take. There were some very kind observers out there that did it for me. And you can get a map of what the magnetic field of different stars looks like at the surface of the star. And if you put that into these simulations, you can then use it to kind of draw all the field lines and look at what the magnetic field would look like all around the star. And you can look for prominences in that case as well, in that kind of modeling, which I have done, but that paper hasn't been published yet. Hopefully it will go through soon. We'll see. So I guess that's more complicated, but I didn't write the simulation package that did that. So
okay.
Yes.
So yeah, so I'll be personally waiting for the paper because I found the small paper, the easier version that you gave me very interesting. So moving on to question number 6, which is, could you tell us a little bit about your academic and related journey that resulted you in coming towards this particular research?
Yeah, so I guess it depends how much backstory you want, but I always enjoyed science as a kid. I kind of thought that I enjoyed chemistry more than physics when I was younger. And by the time I reached the end of high school, I realized that wasn't true. I felt like chemistry was constantly someone telling me, this happens because of X. And then the next year they would say, oh, we lied to you. It's not actually X. It's a bit different to X. And I got so sick of that that I thought, no, I just want to do physics. And everything seems more fundamental there. And so that was kind of how I ended up in physics. And I didn't like maths at school at all. I really struggled with it. And I mean, I still struggle with it, but I've just learned to keep going until it works, basically. And so I didn't want to do experiments. I've never been a practical person. So that was how I ended up doing theoretical physics. And then I guess we talked a bit about how I took certain classes in my undergrad and really enjoyed kind of the aspects of fluid mechanics and well, I want to say magnetic fields, but I actually hated electromagnetism. I found it so difficult. So yeah, I guess I did my master's project and I enjoyed that, and it was on very similar things. So then I decided when I wanted to do a PhD that, you know, I really enjoyed the project and I wanted to keep on doing research. So I applied to do a PhD, and thankfully got in my first choice. So I was very lucky, and I just kind of continued that research really. Yeah, I guess it's a mixture of kind of paths that bounced me here from chemistry all the way to astrophysics.
I think it's also ironical how you say that you were not very fond of maths, but then you went into theoretical physics, right? Because when you think someone's not fond of maths, they would like experimentation more.
Yeah, I think as with everything, as I've got older, I've learned that you can dislike certain areas of things, and that doesn't mean that you dislike everything, you know? So I don't know. I really like calculus, and that's like an area of maths that I like. Right. But that doesn't mean I like all maths. And I guess that, you know, I hate stats, for example, statistical things. I find it so difficult. I don't get it. So I think you can be put off by things when you're younger because your experience is quite limited to certain things. But that, you know, as I got older, I realized that doesn't mean that you dislike everything in it. Yeah.
Those were some very wise words.
I don't have wise words very often, so you're lucky.
It's on recording, so if you want that, I'll share it with you.
Oh, thank you.
Okay, so moving on to our next question, which is question number 8. That is, since you've been carrying on the research that was done probably before you were born, how do you think this research that is done by you could be carried through follow-ups in the future?
That's a good question. I don't know. I mean, I guess I would like it to kind of feed back into the observations. I would be very excited to see that hopefully something that I've done has been able to predict where these prominences might form, and that would allow people to then go and observe on those kinds of stars and hopefully see them. I think like that would be very cool to see it kind of going round in a circle. Yeah, I would like to see that, but we'll see.
Awesome. Let's keep our fingers crossed for that. Yeah, someday in the future you'll be sharing it in your stories that okay, my simulation and the paper that I did, you know, resulted in something like that. So that brings me to the point also that for everyone who's watching at this point, Rose makes amazing illustrations on Instagram. Very simple illustrations, and very honestly, that was actually the inspiration for me when I was thinking what to do, how to, you know, get into science communication. And that was the one idea that I had which stuck around, that okay, this is one thing we could do. We could make art about astronomy. So do follow her. Her link is sliding down the video right now, which is astrophysicist_Rose. Yes, go and follow. So moving on, coming to the next question, which is, can you tell us something interesting about the main object that is the focus of your research? And over here, you know, I do not necessarily mean just the prominences, but even the rapidly rotating stars or the various kind of stars that you studied. And personally, I would also want to know about Speedy Mike.
Yeah. So I guess, like, yeah, I could talk about the stars a little bit. So there are a couple of stars that prominences have been seen on a lot, these rapidly rotating ones, and they are AB Doradus, my ultimate favorite, AB Dor, and also Speedy Mick, which has a very cool name because it rotates very, very quickly. So its proper name is like Bio Mick something. I think it's like to do with it being seen a lot in the microwave area of the spectrum. I have no idea. These observing people, they give crazy names to stars, but it's nicknamed Speedy Mick, which is very cool. So these stars are kind of like the prototypes for looking at stellar prominences, because they have seen a lot of prominences on these stars. And they're very interesting because they're very young stars and they rotate very, very quickly. So they're ultimately kind of like what the sun would have been like when it was a lot younger. And I think for me, that's the interesting thing, to kind of be able to look at these stars and think, well, in the sun's past, this is what the sun would have been like. And it feels kind of nice, that kind of link back to our own solar
So these rapid rotating stars and like Speedy Mike, you said, which rotates very fast. What's the average range of rotation periods for these stars?
So I can't remember Speedy Mix off the top of my head, but AVDOR rotates in about half a day, all the way around, half a day. Yeah. So and very fast.
So wow. I guess and is it? I'm sorry. Please continue.
No, it's fine. I was just going to say, for comparison, the sun, I think, is about 26 days to rotate. So it's a lot faster than the sun.
Right. And I think the sun actually takes around 25 to 30 days to rotate. You know, the way different parts of the sun rotates at different days, and it's 20 to 25. So you saying that it rotated something like them in the past. So was our sun also a rapid rotator in the past?
Yeah. So as a star evolves, initially it starts to speed up its rotation rate. And it's all down to conservation of angular momentum. You probably had to do this in undergrad in your first few years of astronomy. And so this is the point on the curve, I guess. Now I'm trying to look which way this is going to look on the screen for you. But so the star will start to speed up as it's contracting, as it's getting smaller due to gravity, and then it starts to slow down again afterwards. So the magnetic field of stars will allow, well, also in general, there's like a stellar wind. So you might have heard of the solar wind. I'm sure you have. Our listeners might have heard of the solar wind, and other stars have this as well. And it's just kind of an outflow of material from the star, right? But this also takes away angular momentum from the star as it leaves, so the star will start to spin down. So I guess these stars are kind of on this bit of the graph. If you think of this being
the axis and
this being its age, these stars are kind of they're still spinning quite quickly, and the sun is very slow now. But it will have come on a kind of a path like this in its history. So yeah.
So all the young stars are rotating very quickly. Most young stars that are in the process of formation or that stage.
Yeah, so they will start to speed up as they contract. So yes, assuming that they've contracted enough, they will be spinning quickly.
Wow. Yeah, so you know, these stars, I also did a comic a while back. So I also read that these stars are hugely elliptical in shape, right? They are very distorted from the spherical ones. So even the sun rotates is something that, you know, surprises. When I told my younger sister that the sun rotates, she was like, wow, okay, that ball also rotates.
Yeah.
So these things rotate very fast. And imagining the speed with which they must be rotating, because stars are so huge compared to planets and taking just half an hour to rotate. So I think it's safe to say if someone standing on the surface, if they can, they'll be just thrown out.
I don't think I would want to stand on the surface of any star. I mean, I love them, but I'm happy looking from a distance.
Keep a distance. So, continuing with this interesting interview, we come to the question number 9, which is Rose. As we know that you're also a mother, you're also trying to juggle with your PhD's final year. So, how do you maintain a balance between your research life and your personal life?
That's a very good question. I think, as with a lot of people, it was easier before the pandemic. um, and right now, things are a little bit mad, especially since for me, I'm still at home and my toddler is also still at home. So keeping a balance is quite challenging. But I guess in general, I try to with my PhD, I try not to think so much about the number of hours of work that I'm putting in and try to think more about kind of how productive I'm being. At the beginning of my PhD, I was very regimented about working a 9 to 5 and having weekends off and, this kind of thing. And for a lot of people, that really works and that's fantastic. But for me, I didn't find that it was helpful. I feel like I need a bit more freedom to be able to kind of work when the creative kind of streak hits and not work if I kind of don't feel like my head is in the right place for it. So I try to think more about how much work I have kind of produced rather than how many hours I've put in, if that makes sense. And
Yes.
that makes it a little bit easier for me to balance my research life and personal life. So yeah, I guess it's a learning process for everyone because it's different for everyone. But definitely in the pandemic, I have not done a good job of of work or personal life. I don't think, which is probably very common. So
Yeah, I think we are all still, even after a year, we are still adjusting to the quarantine and to the uh, being at home, working from home. Personally, in India, it's opened up at some places, but the lockdown came back again in the UK, so that must have been another, setback. So, just on the same note, what hobbies do you have apart from, I know you make illustrations. What else do you do to take your mind off the research and take a break?
So I used to do a fair amount of running, but recently I haven't been doing that. I guess I still class it as a hobby because I feel like long term it is a hobby. I have a couple of dogs, so I do a lot of dog walking and
Wow.
kind of just getting outside in the fresh air. That I find is a really great way for me to kind of distance myself a bit from work or other things that I might be worrying about. And I also love reading, but again, right now with a toddler, I don't have a lot of time for that. And I tried audiobooks, but I am not very good at absorbing things audially. So yeah, that hobby is kind of put to the side until my toddler learns to sit down a little bit more.
I guess audiobooks will never beat reading books. Reading
Yeah.
books will have their own share of fun. They are unique.
Yeah.
So let's hope your toddler learns to walk and sit at one place very soon. So how old is he or she?
So he is 2 in May. So he's however old that makes him, almost 2. And
2 months?
no, almost 2 years.
Oh,
Yes.
2 years. Okay.
He loves running around and chasing the dogs, and yeah, it's easier in summertime, I think, isn't it, when kids can get outside and run about. Inside, there are a lot of things for him to run into, which are hazardous.
Yeah, totally, totally. Okay, so on that very note, we move on to the question number 10, which is what are your tips to communicate a research paper in under 5 minutes?
So I guess, does this mean like a research paper that you've written or one that someone else has written?
Yes, that you've written.
Okay. So I guess it's about telling a story, isn't it? So you want to kind of tell your story to your audience, and you need to get them engaged, and you need them to kind of see why they should care about it. And I think that really, if you kind of think about how you've laid out a research paper, there's a lot of stuff in there that they're not going to be interested in, and you don't have time for it, right? Because you have 5 minutes. So kind of the abstract is almost the most important thing, because it's already very condensed to the kind of selling your paper. All people really need to know, I mean, it depends on their background, right? But all they need to know is a little bit of background, why you did what you did, and what you found. So I think it's very difficult to do that, but it's all about condensing and filtering out information that isn't important. And that's not an easy thing to do when you have written or done the research yourself, I think. Oh, you have gone silent for me. I cannot hear anything. I don't know.
I'm sorry. I muted myself and I forgot to unmute. Yeah. As I was saying is because when you've done the research yourself, you know there's so much of information in your head, and personally that's always interesting, and you want to be like, I want to share this, and I think also this would help, and then you could follow up with this, and but you have to squeeze it all into 5 minutes, so you have to wisely decide what actually matters at that particular place.
Yeah, and I think that's so difficult to do.
I can totally understand because even when you've not done a research, and when people ask you a very small question and you're passionate about that thing, it quite becomes hard to understand how much time has passed. And in terms of research papers, it's also very hard because they are usually so big, right? They are so long, and most of the research papers, they are so lengthy and so intricate. So you'll have to wisely choose out, okay, this is what matters and this is going to get the attention.
Yeah, I completely agree with all of that.
So I think we've gone through half of our interview. We've gone through 10 questions. So at this point, let's bring up 2 questions asked by one of our viewers. And the first question is that are there any theories that explain how prominences form?
So I guess in the solar community, in the set of researchers that look at the sun, yes, there are lots. In terms of the stellar community, there are some, but there aren't so many. It's a much smaller research area. So I guess it depends on what you mean by how they form, but I think our best guess right now is that you would have some sort of magnetic field that is closed and is kind of relatively rigid, and for whatever reason there will be an instability that in the corona, in the atmosphere of the star, that causes it to suddenly a certain area to get very cold. And because it's an instability, it'll just keep getting colder and colder and colder, and that will mean that you get a condensation or a cloud at that particular location. And assuming that that location is able to support that cloud, then it will stay there. I hope that's helped.
Yeah, it does. So it made me think about the particular word called condensation. So is it like once the cloud form, it rains down on the star?
So yeah, so there is a thing called coronal rain, again on the sun. That's relatively well studied, I would say. I mean, I'm not a solar physicist, so I guess perhaps the solar community would disagree with me. But from my perspective, it seems relatively well studied. And yeah, so you could get that in theory on other stars. There is no reason why that I can think of why
Wow.
you wouldn't be able to get that.
So there's rain on stars, some kind of rain on stars too.
Some sort of weather system.
So the same viewer also has another question that when we observe a total solar eclipse, is these what we are seeing, the prominences?
So you can see prominences when you see a total solar eclipse. I believe. They often kind of look like little loops. So I'm not sure. Again, I'm not sure which picture you've seen. So, or perhaps you've seen it in real life, in which case you're very lucky. But they kind of look like little loops of material, kind of clumped around. So you can see them. Yeah. You can also see them in front of the disk of the sun as well, as kind of little. They're called filaments on the sun. If you see them in front of the star. And they just kind of look like little lines, little, I don't know, kind of little so because obviously you're getting a different perspective if you see them top down compared to if you see them kind of this way around.
Right.
That's
But
not how.
I think over here our viewer has gotten confused a little bit between the corona, the structure of the corona, the bigger structure that we see, and zooming in into the picture. So if that's the confusion, I guess I'll just make it clear that in the main total solar eclipse, the main thing that we are seeing, the waves coming out, that's actually the corona, the atmosphere of the sun that we usually do not see. But if you zoom into that image, then it is possible that maybe if there's a prominence on the disk, on the periphery of the disk, then yes, you can see it. And there are actually great astrophotographers on Instagram. You can find them that even without a total solar eclipse, they've been able to capture prominences and amazing things like that.
So beautiful.
So,
Definitely worth checking it out. Yeah.
so with that, let's continue with the questions that I have for you. Let's come back to them. And now we are going to start with question number 11, which is, how do you deal with mental blocks during research and try to stay mentally healthy?
So I guess we kind of touched on this before when we were talking about how I try to balance my personal life
Yes.
and work life. And for me, that's kind of how that method of working came about, was that I realized that I can spend a lot of time being stuck on something and just kind of sitting there looking at the same equation or trying to understand the same concept and just kind of spend a lot of time doing that and not making any progress, right? So I kind of learned after a very long time that for me, the best thing to do in that situation was to just take myself away from it and not look at it and not think about it, and come back to it when I feel a bit more motivated. And often having a break can help you to kind of process things, I guess, rather than just thinking through the same thing again and again and again and not making any progress. So that I tend to kind of just decide, that's it, I'm not making any progress, I'm going to go for a walk, or I'm going to go and see my son, I'm going to play with the puppy, whatever. I'm going to just do something that's not work related. And initially it was very difficult to do that. I had a lot of guilt about, oh, I should be working, or but with practice I've found I feel a lot less guilty about it, and I make progress a lot quicker than if I just stayed staring at my computer screen. So yeah.
Yeah, that's the perfect way. I guess it happens with everyone, even if you're not doing something as consuming like research. Even if you're reading something, if you're just studying for your schools or things like that, there will always come a point when you're done with it and you're not just understanding it, you're just reading it. So it always helps to just take a step back and just whatever you do, go for a walk, or play around with family and friends, and then just come back to it refreshed.
Yeah, completely. There's a lot of time that you can spend, like you say, you're just reading it, you're not actually absorbing the information anymore. And learning when you've reached that point, learning to recognize that you've reached that point is very difficult. But once you've worked out how to do that, I think it's very good for you ultimately. So
Right, perfect. Yes. So at this point, also, if there's anyone who's pushing themselves continuously, just take a break and take care of your mental health. That's very important. So, continuing with the interview, question number 12 is, how would you explain your research to a kid? I think this
uh,
one's a little hard.
yeah, it is, and it also is very dependent on the kid as well. Like kids can have varying levels of understanding of things. So I guess um, what I would normally say to a kid is something along the lines of that um, use maths to try and predict or look at where clouds might form on stars that are like the sun but a lot younger. And um, I do this because I want to understand what it might have been like in the solar system when the sun was very young.
I guess that's a very simple way of explaining the research.
Yeah,
So,
I guess I didn't know what kind of kid you were talking about. So
I guess every kid would understand that. Even the average kids, the smarter ones, and the below average ones. Clouds, we have clouds over here. See, you know how they form on stars? That's what I'm studying. So
yeah,
I
I
guess
think
that's going to make the kid ask more questions to you. Okay, do we have clouds? Does it rain on stars?
exactly. I think it's always good to pitch slightly lower than you think, because if people are interested, as long as you kind of are enthusiastic, people are interested, they're going to ask you questions, right? So they will ask you questions at a level that will indicate kind of how much they know and how much they understand. And it becomes a lot easier to have a conversation at that point. Whereas
Mhm.
I think if you say something and it's a little bit too difficult or a bit too kind of jargony, or you maybe haven't explained everything so well, people get too scared to ask you more questions. So
Mm.
I try to kind of pitch it slightly under where I think they are, because I think I'm more likely to get something back from them. But I don't know if that's um, true or not. It's just kind of how I felt.
No, I think that's true because if you leave space for them to ask questions, that also creates a conversation between you and them, right? It creates a personal link, and they feel that they are part of the conversation. It's a two-way thing, and they are more, inclined towards being interested towards it in the first place. And that's actually also pro tip for all the science communicators, that we usually when we try to explain science and we are getting into the field of science communication very early, we use these complex jargons of science, which usually the people wouldn't understand, and we try to fill up all the information that we have. So always leave a little space for them to ask you, just a little bit, that I'm not going to tell you why this has happened because you're going to ask me.
Yeah, I guess it's kind of, I don't know how many kind of talks you've had to give in your undergrad, but I guess like when I first started giving talks, even now to a certain extent, I try to predict which questions I think people might ask me. And if I
Mhm.
have maybe not enough time, or there's, I don't know, I'm feeling quite nervous about the talk or something, I try to encourage people to ask a specific thing. Like if you leave a gap on a particular thing and you think someone's going to ask me about that, you kind of lead them into asking that question. And you can do a similar thing with kids, right? You, like you say,
Mhm.
you leave a gap that you know they're going to be interested in, and then hopefully they'll ask you.
Yeah, personally, I think kids are better audiences than adults. Kids will always ask questions, so they are very encouraging, right? I've not given talks when I was in undergrad, but after that, for 2 years, right now I teach kids. So it's always easier when you're standing in front of adults to tell them something, and they're like, okay, yeah, it's interesting, and then they'll go back to what they're doing. So, but kids, they'll always have a question, even if you don't leave a gap, they'll come up with a question.
They are amazingly talented at that. they're so enthusiastic.
Yeah, so we should remain a little bit, that kid that we were earlier. That curiosity should always be there. So, coming to question number 13th, which is, what is a major problem or obstacle you faced on your research to get the data, and how is it overcome? And I think over here, that would also mean that, a particular puzzle that you found it hard to solve.
So I guess in terms of like data, I guess I'll try and answer both aspects there.
Mhm.
And I guess in terms of data, like I said, I don't have that much, but the major difficulty I have is that the data that I want is all in the literature, and it hasn't necessarily all been published at the same time. So I can spend a long time looking through different papers, looking for one single number. And yeah, I guess like on the data aspect, that's the challenging thing for me, is just the amount of time that I spend looking through papers that have been published for one particular number and not knowing which paper it's going to be in. And that's very draining, I guess, and not very rewarding. So I guess from the data side, that I guess was the problem, and there isn't really a way to overcome it except just keep looking. In terms of like puzzles, there was a problem in my master's project which carried through to my PhD, that was very difficult to solve, and it was, I guess it was a differential equation, and it shouldn't have been, in theory, that difficult. But I didn't know how to solve it, and it took me a very, very long time. Ultimately, I did solve it, but it had taken a lot of looking through different textbooks for how to deal with spherical polar coordinates, and getting things into the right form.
Mhm.
And I guess this is kind of what I mean about being stubborn. It was a problem that ultimately took me many, many, many months to solve. And I wasn't just looking at that one problem all that time. I was doing other things,
Mhm.
because I wasn't making any progress with this particular thing. But I guess like that is the way I overcame it, is that I didn't just look at that. I went and I was doing other things as well and taking my mind off it. And at the same time, I didn't just give up on the problem. I just kept trying to find more and more information until I did know how to solve it. Yeah, I think a fresh
And
pair of eyes is very, very valuable when you're doing any form of research.
And this particular differential equation that you were talking about, what did it try to explain?
So when you solved it, it told you what the shape of your magnetic field lines would look like around the star where it had a particular temperature, and that particular field line was colder than the others because I was trying to form a prominence on that field line. So we talked about how prominences are condensations, and they're colder areas of the corona. So it was a field line that I wanted to form a prominence on, and I wanted to know if I would be able to do that, and what the shape of that field line would look like. So ultimately, that gave me the shape of the field line, but it took me a very, very long time.
I guess you'll never forget that equation now. The one crazy equation. So I guess that equation did play a very important role in the research, right? It's basically that's what you've been doing in the research, finding out which magnetic field lines can support prominences.
Yeah, it was impossible to not solve it in terms of the research. I needed to solve it in order to make progress. So, like you say, it was very important. But yeah, sometimes things are quite straightforward, and sometimes things in research are very much not straightforward.
So you'll have to just be stubborn. So at least I guess the one good thing with your data was that even though it was very hard to get because you had to read through all the papers, but it was already there, right? It was not a kind of a problem that would be a more practical kind of a problem that we cannot observe it or we cannot, there's something blocking it, but it was there. But yes, the reading part is very exhaustive when you don't know what to find out, and there's so much of paper, so many papers online.
Yeah, I consider myself lucky I at least didn't have to do the observations because, like you say, there are a lot of difficulties that can come about with that. So I'm glad that I didn't have to do that. Although some people obviously loved that. I'm much happier complaining that I can't find the data in the literature than I would be having to try and do the observations.
So, do you have you? And it's a curious question that I have. That have you used a telescope like the bigger ones, the professional kind of telescopes?
Nope, I've never had to use any telescope for work, so I've never used a big fancy telescope. I do have my own telescopes for kind of just
Wow.
observing, for fun, which I do enjoy. So it's not like I hate all telescopes. I do have them for fun, but I don't. I'm put off, I think, by the big telescopes and all the data, and it's basically because I don't like statistics.
Right.
So,
So, these stars that you're studying, are they bright enough to be observed by your telescope? And if yes, do you observe them and wonder about the things that you're studying about them?
I would love to, but they are all in the southern hemisphere, so I
Okay.
couldn't see them from here, even if I wanted to. Maybe I need to
Right.
take.
So, maybe in the future you'll plan a trip.
Yeah.
So moving on to the next question, which is, assuming the research takes you into academia and teaching, what are your opinions on that? And are you comfortable in the classroom? And what are your hacks to being a good educator?
So I would like to stay in academia, which would involve teaching, of course, of the undergraduates. So I guess I would like to do that. I'm not an incredibly comfortable person in terms of public speaking and things like that. So obviously, like lecturing is essentially public speaking. But I think that these things come with practice, and I think it's a little bit different when you're teaching something compared to talking about your own research. So I have done, tutorials and teaching for the undergrads as a PhD student, and I've always really enjoyed that. It's so fun talking to people about astro and having conversations and kind of solving problems together and things like that. I think it's really fun, and it's really nice to see other people being enthusiastic about it as well. So yeah, I guess the lecturing side scares me more than kind of the teaching side, if that makes sense. I think being a good educator is about listening to your audience, and they'll tell you if they don't understand something. It shouldn't. The idea of a lecture, the word to me brings a lot of connotations of you sat there and someone talking at you, and then they leave, and that's it. And that's not how the learning process works. So yeah, I think it's always important to listen to your students, and they'll kind of guide you. You might be guiding them in terms of general content, but they will guide you in terms of what they need from you. And I think that kind of feedback and that listening is very important.
Yes, that's a very important point that as educators everyone should remember that, yeah, and I think it also happens that when kids come up with questions that makes you dig deeper into the particular topic that you're explaining, right? It often happens that we do not know the answer to a question that has been put up by a student, but it also requires a space to accept that, okay, I can be wrong, or maybe I do not know this.
Completely, yeah. I think so when I first started my PhD, I took on some teaching in the younger years of the astro undergrad, and it was quite daunting for me because I didn't have an astro background. I had a physics background, so I was kind of daunted by the idea that I would be teaching people, when I felt like they would know a lot more than me. But I think that that's not, it's valuable that you can recognize what your strengths and weaknesses are. And for me, I might not have known all of the background like knowledge, but I had the problem solving skills, so I could aid them with all of the kind of problem solving quite easily. And I might not have the knowledge to hand straight away, but I can always go and look that up. And like you say, I learned a lot from doing that. And as long as you're kind of open about the fact that you don't know everything, I think it's fine. And of course, you don't know everything. No one knows everything. So I think it's also important for students to see this, even from a young age. I think kids and everyone really needs to be reminded that just because someone is kind of an expert, that doesn't mean that they know everything.
Right.
So yeah, I think that's important.
Yeah, and I think even the people whom we call experts, they are themselves trying to further understand the thing they are experts on, right? For example, I could say you've done research in prominences, and for me, in the general sense, I would call you an expert on prominences. But then that also means that you yourself, you're in the process of learning about prominences. You're in the process of learning how they form. So the learning curve keeps on going ahead.
Oh, completely. Yeah.
So, coming on to the next question that I have for you, Rose, is uh, okay, this is one of my favorite questions. What is the most recent new thing or news that you learned related to any topic?
Any topic at all, or
Any topic at all. It could be any random topic, even outside physics or astronomy, that was interesting to you and you learned about it recently.
So I guess I learned yesterday actually that wood pigeons can live for 40 years. And this amazed me because I thought, pigeons are quite small birds, and I didn't expect them to live, 40 years is like almost twice my age. I mean, not quite, I'm 26, but like that's a really, really long time. And I was very amazed by that. Biology never ceases to amaze me.
Yeah, so there's a pigeon that's older than us and probably more wiser.
Yeah, exactly.
Wow, I did not expect pigeons to live that long. I wish
Yeah,
dogs lived that long.
it would be amazing if dogs lived that long. That would make me so happy.
I can totally relate with that feeling. Uh, so, uh, okay, so moving on to the next question, which is if it was not for this subject, what would you choose to do in life?
Um, do you mean like now or as a kid or?
As a kid, in general.
Okay. So when I was a kid, I either wanted to be a scientist. I guess I didn't have a word for physicist back then. Um, but yeah, I either wanted to be a scientist or I wanted to do archaeology. So
Wow.
I probably would be doing archaeology.
But I would ask that what do you personally think? Is archaeology, does archaeology still have a future? Because, I do not know a lot of archaeology, but I assume that, a lot of things have been found, and there's nothing for you to discover further. It's just to, further understand, but not to discover.
I think that people have lived just about everywhere, right, throughout the existence of humanity. So I think there will probably always be stuff to discover. I think that it will probably drop off, I imagine, because we will have found more and more. But I think there will probably always be stuff to discover. I guess just as other people might have a incorrect idea that all astronomers look through telescopes, I probably have an incorrect idea of what archaeology is. And probably for a lot of people, it doesn't involve going and digging things up. It probably involves looking at finds and doing more theoretical research, I guess.
Yeah, because that's what I thought. The archaeologist would be a person with a hammer and nail, and searching something in the soil.
Yeah. I mean, I don't know like anything about archaeology except for watching a lot of TV shows about it. I'm
Mhm.
definitely have no actual knowledge about it. But yeah, I guess it's probably not what I think it is. But I definitely would have gone down that route if I had not ended up where I am.
Yeah, and I think we could also speak of a field like astroarchaeology. Would that make sense?
I guess it will be coming, right? I mean, eventually we will be um, I imagine eventually we will be on other planets or whatever. And I guess there will be stuff to discover there. I guess if we go to the moon now, we could
Hmm.
do archaeology in terms of our history on the moon. So yeah, I guess it will be a thing ultimately, which is very cool.
So a new subject coming up in the future.
When I'm
But
very old,
I think that would be more cool. Going to different planets and studying what the civilizations of those planets were like. Reminds me of Star Trek and Star Wars.
oh yes, yes, I love both.
Same. I'm not going to choose. I'm not going to get into the fight of Star Wars or Star Trek. I want both, and I want to be out of that fight.
Yeah.
So, coming on to the next question, which is there any particular piece of misinformation or pseudoscience that is common and pisses you off?
um, I try to be understanding of people who have kind of misinformation or pseudoscience beliefs because either they have been miseducated or I feel like if it isn't that and they've kind of, for example, gone into the whole flat earth belief, um, it's kind of a cultural thing. They're potentially looking for something that's more, I don't know, um, friends and people with common, I don't know. I don't think it's necessarily always about the pseudoscience, I guess is what I mean. Um,
Mhm.
so I try to be understanding, um, but yes, there are things that irritate me. The idea of a flat earth irritates me. I I love Discworld where there is a flat earth. But like if you've ever been on a plane or seen a picture, it's quite, you know, uh, you can do your own experiments to prove that the earth is not flat. So I am irritated by a lot of such things. Vaccines causing autism and all this kind of thing. They all irritate me, but I try to be understanding and try to combat it in a positive way, but I can't claim that it doesn't annoy me.
I can see the effort that you're putting in. I try to be understanding. I try to explain, but these people they do not get that the Earth is not flat.
Yeah, you can only, I think the thing is, you can only do your best in explaining things, and people don't always want to listen, so if they're open to listening, then you can open a discussion about it. But if they don't want to discuss it, then, and they just want to be fixed in their belief, which it is a belief at this point, then you can't do anything about it. And there's no point, because it will irritate you a lot. Science hasn't always done a good job of explaining itself to people, and it hasn't always done a good job of being there for everyone, rather than a minority amount, kind of set of people. So I can understand how people end up having these views, but it's difficult when they don't want to have open discussion about it.
Yeah, so the point that you say that even though science answers everything, which is a very good quality, it has been something that has been more of a privilege to be familiar with for a lot of people. So I guess that's directly related to the next question. That is, what are your views on science communication? And if you have any, I know you have an experience with that, so please share that with us.
So I think that every scientist should participate in science communication. I think that as a scientist, you have a responsibility to share your knowledge with the public. Especially, some of us, like, for example, my PhD is funded by an EU funding body. So, like, essentially the taxpayers of everyone that was in the EU and the UK before we made the decision that we did, they've all essentially paid for my PhD, right? So I have a responsibility to share my knowledge and my experience with everyone that wants to listen. That doesn't mean everyone wants to listen, of course. But I think as scientists, we are very lucky. Like you say, it's a privilege to have a lot of the knowledge that we have, and to have had the education that we have. Not everyone has had that, and so it's important to pass that on to everyone, whether they're older people who never had the opportunity, younger people who haven't had the opportunity, or maybe young people, to encourage them to follow that career path, regardless of who they are. So I think it's very important, and I think every scientist should be doing it. There's so much variety as well, So I mentioned I'm not really a big fan of public speaking, so I have done some, but I'm not really a fan of it. So a lot of the science communication I do doesn't involve standing up and doing a lot of public speaking, because that's not really what I love doing. It's obviously something that lots of people love doing, so that's kind of an area that they might want to go into. But scicomm is massive. There are so many things that you can do. I mean, like, right? Like, there are so many different things that you can do in scicomm, and finding the area that you like and the skill set that you have and that little niche, it takes a while sometimes, but that's then, where you'll feel comfortable, but you'll still grow and you'll learn a lot of skills. So you get something back from it, but you don't have to do something that's kind of ultimately terrifying to you. So yeah, I think there's a responsibility, and I think it's also important that you find an area that you kind of like doing. So for me, I love chatting about astro, so this is so fun, and I love making little cartoons, so that's kind of what I do on Instagram a lot of the time. I've not had quite so much time recently, although I am working on a new cartoon project. So
yeah, I did notice your illustrations have not been so often lately.
Yeah,
I've been missing them.
Don't worry, they're coming soon. I have a new project, so yeah, and I'm always looking for inspiration, right? So if anyone listening, or if you have any suggestions for posts that I should do, you're always willing to drop them my way. So yeah, you find something that you like. You ended up doing cartoons as well, so we have a lot in common. It's obviously a good place to be.
Yeah, it's more comfortable because you can take your time to calm in front of the public and let them judge you. Until then, you can just put cute cartoons to them that okay, yeah, this is over here. Just enjoy this. So how did the idea of scientific illustrations that you do come to your mind?
I guess I've always liked kind of doing little doodles and little kind of pictures. I've never been amazing at art. I'm not like a fine art person.
Mhm.
And some people in my family are, and it's amazing. I wish I had those kind of skills, but I don't have the patience, is the honesty. Um, I always enjoyed kind of expressing myself kind of artistically, I guess. And I just felt that cartoons are very like friendly. Everyone likes just a little cartoon. It's not too serious. It's not. I don't know. I feel yeah, it's quite friendly, and I think that it can be a good way to express scientific ideas
Mm.
because it doesn't scare people off so much. Even just to get them interested, even if they don't take everything from the cartoon, they might not take some of the ideas. They're still potentially interested and made a bit more enthusiastic about it. So yeah, I think the overlap between science and art is very important.
Yes, and I guess pictures always do a better job at explaining harder concepts than words of written sentence. So if you draw something and you use the arrows and you use the graphs and it all becomes more clear to someone.
Yeah, I definitely am a visual learner, so I agree. I think that having a massive text kind of explaining something, it's not
Mhm.
always a great way to do that, and it's also not very accessible. You need to be able to have potentially quite a high reading level. You need to be able to read in
Mhm.
that language um, and things like that. So I think a cartoon, people can get something out of it, and they might not all get the same thing out of it, but that's fine.
Perfect. So if anyone is in science over here, this is your shout out to go and get into science communication the any way that you're comfortable with, be it speaking, drawing, or theater, or anything that you find you could use to communicate your research. So, coming on to the next question, question number 19, that is name one scientific figure of inspiration for yourself and why.
Oh, there are lots of inspiring scientists. I guess on a more personal level, my PhD supervisor is a scientific figure of inspiration for me. She's she's a fantastic scientist, but she's also a really great mentor. She's always, she never judges me if I'm like, I have no idea what you're talking about, or I don't understand this, or I have a question and I think it might be a stupid question, but I'm going to ask it anyway. And she's never judgmental about it. She's always willing to answer things, even if she's just, told me the answer 2 days ago and I've forgotten. She'll be very patient and repeat it again. And I think having someone who is a fantastic scientist, but also very encouraging to kind of younger, I guess, generations of scientists, I think I find that very inspirational because it's so fantastic seeing someone who is, a normal person, not just a scientist in the stereotype of someone who only thinks about their
Mhm.
work and that's all they think about.
Yeah.
It's so inspirational, and there are so many people like this. So I'm not claiming there are no other scientists that do this. There are a lots
Mhm.
of people out there like that, but I found that has been very inspirational, and it's been fantastic for me because it's helped me grow a lot and be comfortable asking questions rather than feeling like I'm stupid all the time. You know, um,
Yeah.
so yeah, I hope that I'll be able to emulate don't know what's wrong with my voice today. I hope I'll be able to be similar one day once I'm further on in my career.
Yes, and I think that's very important for the mentor to be the kind of person that you're talking about, because a lot of the PhD work revolves collaborating with that mentor, learning from them. And if they are not very patient, or if they are, a lot of, I've also heard about cases where the mentor is not very friendly, and that could be an added on stress to the stress that you already have about the research and the PhD life. So it's actually a good answer, because when we ask this question like this, people usually answer about historical figures or celebrities, but it's very important to also identify that someone who's as close to you, like a mentor, and even then they are giving you the inspiration that you need and the support that you need.
Yeah, I think it's very easy for inspiration to be a word that we associate with like fantastic, I don't know, scientific breakthroughs or like celebrity figures, like you say. And actually, like, that's not the only thing that we can be inspired by. We can be inspired by other things. So yeah.
Awesome. So we come to the next question, and this is going to be the second last question for this interview, which is, what is one advice you would want to share with prospective graduates?
Oh, there's lots of advice that I think is valuable. I think that it's important to not feel, I guess, coming back to points we've made before, not feel like you've been cornered into something. Just because you have graduated with a specific degree, that doesn't mean that your entire future is laid out for you. Your skills are going to be applicable to a lot of different things, a lot of different careers, and many things you might want to do in life. You could leave with a physics degree, you could go into astro, you could, if you wanted to stay in research, you might end up working in a chemistry or maths department. You could even be doing like biophys. So you could be doing biophysics, and then you're more down the biological route. So you've still got like all of science there. You might go into like science communication. You might start doing more art related things, even though you have a science degree. And you're still going to be applying a lot of the skills that you've learned. I mean, you might do something completely different and like work in finance or, something like that. So like, I think it's so important not to feel like your entire career and your entire life has been planned out just because you've graduated with a specific degree. It's about thinking which skills you have developed and what you can apply that to, rather than thinking like, oh, I must do this with my life now. Yeah.
Yeah, that's a very important piece of advice, that even though the decisions you're making are important, they are not going to decide the whole future. So it's
Exactly.
okay to agree, okay, maybe this was a bad decision and let's try to do something else. So coming on to the last question, another one of my favorite ones, which is, if you could suggest one book or author of any genre to someone, what would it be?
So I guess the author that I would recommend would be Terry Pratchett. I think uh, he's very famous, so obviously a lot of people will have already read his books, but I find them very refreshing, and I enjoy I guess, the comedy aspect of it, the light humor, but also I feel that his books are constantly some sort of comment on society or some comment on a certain aspect of society, and that's taken into a kind of fantasy, I guess, kind of fantasy setting, and so it becomes a lot easier maybe to see that certain aspect of society that he's writing about without having all of your emotions attached to it, whether that's a comment on certain politics, or whether it's a comment on gender related things. I think in the real world, we have a lot of emotions associated with these kind of ideas and these discussions. But once you take it into a fantasy world, you're kind of removed a little bit. So you kind of see it from a different perspective, I think. So yeah, but they're also just very enjoyable and funny to read. So I think they have a lot of merit.
Yeah, so I've noted down the name. I'm definitely going to start reading his books. Unfortunately, as you said, a lot of people must have heard of him. I did not, and I'm going to make sure that I read out his books. So, with that, Rose, I think I'm done with the questions that I had. And shall we move on towards the questions in the comments?
Yeah.
Perfect. So, the first question that I want to ask you is, okay, so here's a question. Is the ultimate fate of astrophysicists joining academia after postdocs, or is there any possibility of all-time research?
Of all-time research.
Yeah, I think the viewer wants to ask whether they could be involved in research and not teach.
I see.
Is that possible?
So I guess if you didn't want to teach, you could go into astro research in different institutions. So some universities you don't have to teach in, so you might go there. Or you could be in a different institute that is specific to research. So, you work, for example, at NASA or ESO or ESA, or I now can't think of any others off the top of my head, but there are lots of kind of Max Planck Institute and things like that where you could get positions that you don't have to teach in. So yeah, you don't have to teach. I think that you should teach. 'Cause I think it's important to encourage and motivate the younger generations. So, but you don't have to. And if you really are not a fan of it, then I understand. I don't think that people should be forced to do it, because I think that teaching should be a job that is done by people who want to do it. But I think a lot of
Right.
people can learn to want to do it, I guess, is what I mean.
Yeah, because the field of teaching, even I was not very curious about it. As kids, when we say I want to become a scientist, and we use a different sentence for, okay, I want to become a teacher. We do not actually, converge them. But in the course, even when I got into teaching, I found out that it actually makes you a better person of science when you teach someone else, right? It clears up your concepts better. So it's just going to help you. But over here, I guess the difference would come who's more comfortable teaching.
Yeah, I agree with.
So coming on, the last question that I have for you is the condensation of clouds over the stars, is that what causes the dark spots on the sun?
So I don't know if you mean sunspots. I'm gonna assume you do. So I guess the confusion might have come about when we were talking about if you have a star and you have a prominence and the prominence passes in front of the star, then it can look from your perspective like the star has got dimmer because something is blocking out the light. If you were talking about if you look at a picture of the sun and there's kind of some dots on it that we call sunspots. Do I have a picture up here? I do have a picture up here. These things are sunspots, and you can get these on other stars as well. They are caused by areas of very intense magnetic field on the surface of the star. So they are kind of linked to prominences, because where you have a very strong magnetic field, you probably will end up with a prominence at the top of the loop, and you'll have little sunspots at the kind of the feet where the loop magnetic loop goes into the surface of the star. So depending on which of the two things you were talking about, yeah, they are related, but the prominence doesn't cause the sunspots.
And I guess that answers the question. I'm so sorry I said that was going to be the last question, but on the course that you are answering this, I remembered that when I was reading your paper, you mentioned about papers who found out prominences in other stars through binary systems. So when another star came behind it, the light passed through the clouds, and that was pretty clear. But what I was curious about is, how do we detect stars around rapid rotating stars, and what do you mean by slingshot prominences?
So slingshot prominences are the prominences that form around the rapidly rotating stars, and they just have a different name to differentiate them from kind of prominences in general that are kind of thought of as being around the sun. They have their name because they are very, very far out from the star. And if you think about what would happen, I'm laughing because someone at work did a demo of this, and yes, if you think about having a sock and you fill it with porridge and you spin it around your head, then it will start to kind of be pulled further out from you, right? So you can feel it kind of being pulled away from you. And you kind of see a similar thing in these slingshot prominences. You have a magnetic field, and the star is rotating really quickly. So material from the star is getting shoved to the top of the loop, just as your porridge in your sock would be getting thrown very far out. And I guess if you were to release that, it would kind of ping off. And this is where the name slingshot prominence came from. It was, I think, maybe given name-wise as a kind of an explanation, and it kind of stuck, even though it was a little bit colloquial, maybe. But it's so you kind of, I guess, it's a good way of explaining very quickly that you're talking about these specific type of prominences that are really far above the surface on rapidly rotating stars, not kind of normal solar prominences. Yeah.
Thank you so much for answering these questions and all the questions by the viewers. And I hope everyone watching the video learned a lot. I personally enjoyed the conversations so much. I learned about the prominences, and until now I thought prominences were only loops around the sun, but now I know they're also clouds, and it's actually raining down. So thank you so much, Rose, for joining us today. And before we say bye to our friends, would you like to say something?
Well, thank you for having me. It's been really, really fun to chat with you all, even the audience that are kind of invisible to me. Yeah, it's been really fun, and it's really fantastic that you are doing these. I guess I want to call them podcasts. I don't know if that's the right word for it. And I'm really excited to see all the other ones. I think these are really fantastic. So, yeah, thank you for organizing these.
Thank you so much. That was completely my pleasure. And yes, even I'm excited to see what amazing interviews are lined up, right? So that we can all learn in the process. So, with this, thank you everyone for joining in. This was the second episode of Keeping Up with the Universe. And I'll be seeing you in the next episode that I hope will come very soon. Bye bye. And do not forget to look up at your stars this night. Have a nice day, everyone. Thank you.